Introduction to Pydantic. Pydantic is a Python library for data validation and settings management. It uses Python type annotations to validate data at runtime. Pydantic ensures data is the correct type, shape, and format. Why use Pydantic? It reduces bugs by catching errors early. It helps you write clean, readable, and predictable code. Real-world uses. Web APIs, like Fast API, for validating input. Data analysis scripts for checking data schemas. Configuration management. Running the cell now. Ignore warning messages in the notebook. To install Pydantic on Windows, run this command in your terminal. Pip install Pydantic. Import BaseModel from Pydantic. Running the cell now. This code sets up our environment by importing Pydantic's BaseModel, the foundation for creating data models with built-in validation. Although it produces no output, this step is crucial as it prepares us to define structured data with enforced types, which is the core purpose of Pydantic. Next, we'll see how this import enables automatic data validation in action. Core Pydantic concepts. The main object in Pydantic is the BaseModel. You create models as Python classes that inherit from BaseModel. Models use type annotations to specify expected data types. Validation runs automatically when you create a model. Running the cell now. Create a simple model called person, inheriting from BaseModel. Define a name field as str. Define an age field as int. Create a person instance with name Alice and age 30. Print the person object. Running the cell now. This output shows the result of creating a Pydantic model instance, where the values match the specified types, a string for name and an integer for age. Notice how Pydantic automatically validates and stores the data upon instantiation, and the printed model clearly displays the key fields and their values, illustrating the core concept of defining and using models with type annotations. Create a person with name Bob and age given as a string. Print the person object. Pydantic auto-converts compatible types. Running the cell now. Here, you can see the printout of a person model instance where the age was given as a string 25, but Pydantic automatically validated and converted it to an integer 25. This highlights how Pydantic enforces and coerces types based on your annotations, ensuring your data matches the expected types without extra manual checks. Beginner examples. Defining and using a Pydantic model is simple. Let us see how to access fields and validate data. Running the cell now. Print the name field of the person object. Print the age field of the person object. Running the cell now. This output shows how to access and print fields from a Pydantic model instance easily. Notice that the model correctly holds the data we defined, here the name Alice and age 30, demonstrating both data storage and validation done by Pydantic under the hood. This confirms that defining and using Pydantic models to work with structured data is straightforward. Convert the person object to a dictionary. Store it in person_dict. Print the dictionary. Running the cell now. Here, the output shows the dictionary representation of the Pydantic model instance, with keys matching the model fields and their corresponding values. This illustrates how calling .dict converts the validated model data into a standard Python dictionary, making it easy to access or manipulate fields like name and age. Create a dictionary with name and age. Assign data for name and age. Create a person from the dictionary values. Print the new person object. Running the cell now. Here, the output shows a Pydantic model instance created from a dictionary, with the field's name and age correctly assigned. This demonstrates how you can easily instantiate a model using keyword unpacking, validating, and accessing data in a clean, structured way. Notice how the printed output confirms the model fields hold the expected values, reflecting successful data validation and assignment. Intermediate examples. Pydantic supports default values and optional fields. You can use type hints like optional, int. Running the cell now. Import optional from typing. Create a user model with username and email required. Username must be a string. Email must be a string. Bio is an optional string and defaults to none. Create a user object without specifying bio. Print the user object. Running the cell now. This output shows the user model instance with username and email fields populated, while bio is set to none by default. Notice how the optional bio field, typed as optional str, is not required during initialization but is included with its default value. This demonstrates how Pydantic handles optional fields with default values seamlessly. Create a user object, this time providing the bio field. Print the new user object with the bio included. Running the cell now. This output shows a Pydantic model instance where the bio field is provided, demonstrating an optional field with a default of none if omitted. Notice that only the explicitly set fields appear with their values, confirming how Pydantic handles optional fields gracefully while enforcing required ones like username and email. This supports the lesson's focus on using optional and default values in your models. Show what happens if email is not a string. Try to create a user with email as number. Catch exceptions if they occur. Print the validation error message. Running the cell now. This output shows a validation error raised by Pydantic when trying to create a user with an invalid email type. Notice that the error clearly indicates the email field expects a string, but received an integer instead. This demonstrates Pydantic's built-in type enforcement, which helps catch data issues early in your models when using optional and default fields. More intermediate features. Pydantic supports nested models and lists. You can model data that contains other models. Running the cell now. Create an address model with street and city. Street must be a string. City must be a string. Create a user with address model with username and address fields. Username must be a string. Address must be an address object. Create an address object. Create a user with address with the address object. Print the user with address. Running the cell now. This output shows how Pydantic models can be nested, with the user with address model containing an address model as a field. Notice how the nested structure retains the detail of both user and address information, demonstrating Pydantic's ability to cleanly represent complex, hierarchical data. This is key for modeling real-world data that naturally includes nested objects. Convert the user with address instance to a dictionary, including the nested address. Running the cell now. This output shows how Pydantic handles nested models by converting them into nested dictionaries. Notice that the address field itself is a dictionary with keys for street and city, reflecting the inner model structure. This demonstrates Pydantic's ability to model and serialize complex, nested data cleanly and intuitively. Advanced examples. Pydantic models can validate and parse JSON data. You can customize validation logic with special methods. Let us see an example using custom validation. Running the cell now. Import validator from Pydantic. Define a product model with name and price. Name is a string. Price is a float. Add a custom validator for the price field. Define a method for validation. If price is less than 0, raise a value error. Return the price if valid. Create a product with a valid price. Print the valid product. Try to create a product with a negative price. Catch and print any validation errors. Running the cell now. This output shows that the product model successfully created an instance with a valid positive price, as seen with the book product. The key takeaway is the custom validator on price, which raises a clear error when a negative value is provided, demonstrated by the chair product raising a validation error. This highlights how custom validation ensures data integrity when parsing JSON or other inputs. Import the JSON module. Create a JSON string for a product. Parse the JSON string into a product object. Print the parsed product. Running the cell now. This output shows the successful parsing and validation of JSON data into a Pydantic product model, with fields name and price correctly populated. Notice how the JSON string is automatically converted into a model instance, demonstrating Pydantic's ability to handle JSON input seamlessly while enforcing the model's data structure. This reinforces the lesson on using custom validation to parse raw JSON data effectively. Define an order model containing a list of product objects. Products is a list of product objects. Create an order with two products, pen and notebook. Print the order with its products. Running the cell now. This output shows that the order model successfully validated and parsed a list of product objects, preserving each product's name and price. Notice how the products field contains a list of fully constructed product instances, demonstrating Pydantic's ability to handle nested models. This confirms the lesson's point on working with lists of objects in custom validation scenarios. Error handling and debugging. Pydantic raises clear error messages when data is invalid. Use try except to catch and handle errors safely. Let us see an example. Running the cell now. Try to create an order with price as a string instead of a float. Catch any exceptions. Print the error message if validation fails. Running the cell now. This output shows Pydantic catching a data validation error because the product price was given as the string free instead of a number. Notice how the error message clearly points to the exact problem, the first product's price field, helping you quickly identify and fix invalid input. This demonstrates the lesson's intent, using try-except blocks with Pydantic to safely handle and debug input errors. Best practices. Use type annotations for all fields. Use optional for fields that can be empty. Handle exceptions when loading data from external sources. Use validators to enforce extra constraints. Convert models to dict for JSON or database storage. Running the cell now. Mini project, simple address book. Let us build a tiny address book using Pydantic. It will store a list of people and their contact details. We will create, add, and display contacts. Running the cell now. Define a contact model with name, phone, and optional email. Name is a string. Phone is a string. Email is an optional string and defaults to none. Define an address book model holding a list of contact objects. Contacts is a list of contact and defaults to an empty list. Create an empty address book. Print the empty address book. Running the cell now. Here we see the initial state of our address book, which starts with an empty list of contacts as expected. This confirms our model correctly initializes with no entries, setting the foundation to add and manage contacts in later steps. Notice the shape is a list inside the address book, ready to store multiple contact objects. Create a contact for Anna with name, phone, and email. Create a contact for Ben with name and phone only. Add Anna to the address book. Add Ben to the address book. Print the address book with two contacts. Running the cell now. The output shows the address book now contains two contacts, Anna and Ben, with their respective phone numbers and emails. Notice that Ben's email is none, highlighting how optional fields work in Pydantic models when no value is provided. This confirms that adding contacts to the list successfully updates the address book, which is key for managing entries. Loop through all contacts in the address book. Start the for loop. Print each contact's name, phone, and email. Running the cell now. This output lists all contacts currently stored in the address book, showing each person's name, phone number, and email. Notice that while Anna's email is provided, Ben's email is none, highlighting how missing optional data is handled. This demonstrates the code's intent to retrieve and display stored contact details accurately, even when some fields are empty. Thank you. If you enjoyed this lesson, please like and subscribe. Find more tutorials on our channel. Running the cell now.